Assalamu alaikum everyone. Today we'll start Numerical 2.9 Kinematics Unit 2 9th class. The statement of this numerical is when brakes are applied, the speed of the train decreases from 96 km per hour to 48 km per hour in 800 meters. How much further will the train move before coming to rest, assuming the retardation to be constant? To solve this numerical, we have to enlist the given data. Consider this box as a train. It was moving with 96 kilometers per hour. When the brakes was applied, the velocity of the train is decreases with the uniform retardation to a value of 48 kilometers per hour. During this decrease in the velocity, the train covers a distance of 800 meters. But as the retardation is uniform, so the train keeps on decreasing its velocity and ultimately it stops after covering some more distance. That distance is called S, and its final velocity is 0 kilometers per hour. To solve this problem, first we have to find the retardation with which the velocity is keep on decreasing. To calculate the retardation, we will split our numerical into the two parts. The first part, in which we know that the train was moving with 96 kilometers per hour, and as the brakes were applied, its velocity will keep on decreasing and reach 48 kilometers per hour, and during this it covers a distance of 800 meters. So we can use third equation of motion to calculate the retardation. 2as is equals to vf square minus vi square. So to calculate the retardation, this is the s, the distance covered by the train, this is the initial velocity of the train, and this is the final velocity of the train. But the initial velocity and the final velocity were given in the units of kilometers per hour. So first we have to convert the kilometers per hour into meter per second. To convert the kilometers per hour into meters per second, 96 multiplied by 1000 and divided by 3600. This is our initial velocity in meter per second. Similarly, we can calculate our final velocity in meter per second, 48 multiplied by 1000, then divided by 3600, 13.33 meter per second. Now putting these values into the third equation of motion, we will get the retardation value. 2a into 800 meter vf square 13.33 meter per second whole square minus 26.67 meters per second whole square. Now after an acceleration a is equals to 13.33 meters per second square minus 26.67 meter per second square divided by 2 into 800 meter. Negative 0.334 meter per second square is the retardation when the brakes was applied. So when the brakes was applied, this is the retardation with which the velocity is keep on decreasing. Let's recall our numerical the train first was moving with 96 kilometers per hour. When the brakes was applied, its velocity decreases to 48 kilometers per hour, and it covers a distance of 800 meters with a uniform retardation. A is equals to negative 0.334 meters per second square, and the velocity of the train was keep decreasing, and finally the train reaches at the rest position when the velocity is 0 meters per second. So for this part we have to calculate the distance that train traveled before stopping, S. To calculate this, again we have to use third equation of motion. 2as is equals to vf square minus vi square. So in that case the final velocity is 0 meter per second when the train stops, and the initial velocity is 48 km per hour. We have to convert the 48 km per hour into meter per second, that is equal to 13.33 meters per second. 2 into minus 0.333 meters per second square into s. So now s is equals to 0 minus 13.33 meters per second whole square divided by 2 into negative 0.333 meters per second square. So s is equal to 266.8 meter, the distance that train covered before stopping. So that's all about this problem. If you understand this problem, share my video, like my video, and subscribe my channel. Thank you very much.